Okay, first of all, very welcome to my presentation, which will feature or answer why quality in grinding media is good for business, and particularly business for our customers. My name is Christer Elbom, and I'm managing the only manufacturing unit for grinding balls in the Nordic countries. It's located in Forsbacka, close to Gävle in Sweden. Some words about the company. Ovako is one of the leading manufacturers of steel when it comes to engineering steel in the world. We are one of the leading companies in steel making in Europe, and we are the biggest consumer of scrap, recycled scrap, in the Nordic. Some words about our product palette. Most of the tonnage is produced as bars in different sizes, shapes. We also, as you can see, profiles is on the program. We do it hot worked bars, we had cold worked. We also produce rings up to size of 4 meters today, tubes, and of course what we'll be talking about today is the grinding media as grinding balls, but also as grinding rods. What makes us special in this case is that we are probably one of the very few manufacturers of grinding media with their own steel mill production backing up. And we can then from that choose the best optimized solution when it comes to steel making, forming, treatment in order to optimize the performance under different working conditions during grinding. Our focus area is first hand is wet grinding, and it can be minerals containing iron. It can be iron, which is normally the oxidic mineral, copper, zinc, lead, silver and gold. It can also be grinding for cement industry, which is mainly grinding sand and limestone, or it can be soft minerals like talc or graphite. We also supply for industry of recycling, which is in first hand taking care of slags from the metallurgical processes. It can also be glass that is recycled, or it can be like cemented carbide tools that are grinded. In the grinding process, our customers are often focusing on the output, tons per hour, energy consumption, kilowatt hours per ton, or the wear of grinding media, grams per ton or grams per hour. For a given grinding ball or rod, the steel chemistry and in combination with the microstructure are the dominant factors for controlling wear resistance. A quenched high carbon martensite has better wear resistance than a low carbon martensite. Increasing hardness always leads to improved wear resistance, and that's the reason why we very much focus on rather high carbon containing alloys of steels. Tempering increases always the wear resistance. So that means that after quenching, the grinding media need to be tempered in order to gain the best wear resistance. And of course, at the same conditions after tempering, hard carbon martensite has always proven to be better than low carbon martensite. If you have different kind of structures, normally we try to focus to have the same kind of structure in the grinding media. As we can see that it is performing differently if we have a mixed structure, but also the importance of the grain size in the grinding media is very important, and that reflects that is especially when it comes to the wear, how the wear is progressing, is to avoid formation of cracks and also the progression of cracks in the grinding media. That means that sometimes a grinding media with a lower hardness can have better performance than with a higher hardness if you can control the conditions. So our message is that if you can control the conditions, that you have the same kind of steel with very small variations and the same kind of treatment of the steel, that means that you can control and minimize the variations in your grinding operation. And of course, the manufacturer of grinding media, a number of quality gates are requested, so we can follow and monitor that our variations are as small as possible. Choice of material, that means that selecting steel is a very important part of the process in order to optimize the conditions in the grinding. We have today a number of standard grades that we are using on rods. There are around 1% in carbon. Next level, which is slightly softer, is 0.9. And then we have another at 0.8. So we can see different depending on what kind of minerals you are grinding. But we can also, as a steel producer, offer a tailor-made solution. For the grinding balls, we are operating since some time with two different grades. One is where we control the grain size, is the B, where we are operating with a carbon content of 0.8, kind of ectectidic kind of steel, where we can guarantee a surface hardness from around 62, 63, which is more or less also the core hardness of the grinding ball. We are also, for certain minerals, particularly in cement industry, are using the 51 CRV4 grade, which can be offered then in sizes from 30 millimeters up to 70 millimeters. We'll reach hardness levels of 62 to 66 Rockwool C. Or we can define, if you have special request on toughness, hardnesses between 50 and 66 Rockwool C. Important in the grinding process as such, where we try to minimize the variations of the grinding media, it also helps to also see variations in other factors related to the grinding, which could be the lining, and in combination with the grinding media, or it can be variations in the ore that is mined. It can also be affected by the speed of the mill or the levels of the water, ore, and grinding media. So in order to focus on the variations that really are affecting the costs, it's important that we can have a grinding media that is very constant. So stable levels, or let me say, to be able to maintain high and stable level on the grinding media supplied into the grinding process is also gives the best opportunities to have a good economy, which is the benefit of our customer. Thanks for your attention, and if you have more questions, we are in the stand in the hall next by here, first on the left hand.